Okay, so looking at this question. Now when it comes to these questions here, you are going to need a ruler and you are going to need a compass. So for looking at this particular question, if you feel like you could draw this and potentially draw a little sketch of this, not worrying too much about the scale, then you could possibly follow along. You probably need the shape to be about the same size as it is shown on potentially a computer screen, but obviously it's going to need to be bigger if you are watching it on a mobile device. But if you could draw this shape around about this size, you could probably follow along with some of these questions. I am going to do some questions for you to have a go at where you can draw them a little bit better if you choose, but otherwise this will just be a good instructional video as to how to tackle these problems. So if we look at this first question to start with, it says the diagram shows a plan of a park, and we've got the diagram shown on the screen. It says a bench in the park is equidistant from A and from C, and we'll discuss that in a moment. It also says that the bench is exactly 700 meters from D, and it says mark the position of the bench with a cross. So if we're looking at this particular question, then we need to figure out this first bit of information. So where it says the bench is equidistant from A and from C, it means an equal distance from A and from C. Now that doesn't necessarily mean that it's right in the middle of A and C. If we kind of imagine where that would be, we would maybe imagine it's somewhere here. So it doesn't mean that it's there, because it can be equal distance over here potentially, or potentially over here, where it is still the same distance away from A and C, but obviously just not right in the middle. So if we think about what that means we actually have to do, we're going to have to do a perpendicular bisector for the line that's joining them up. So the first thing that we're going to want to do on this question is we're going to want to join A and C. So if we do that, obviously you want to put your ruler on the diagram from A and join a line up to C. That is now going to allow us to do a perpendicular bisector. Now with all of these questions, it is going to involve those constructions, perpendicular bisectors or an angle bisector. So do make sure, if you are watching this for the first time, that you go into the description and watch the video on angle bisectors and perpendicular bisectors. So now that we've drawn that line in, we're going to actually construct a perpendicular bisector, as that is going to split this line perfectly in half, and it's going to show us all of the points that are equal distance or equidistant from A and from C. So in order to do this, we don't actually need our ruler for this particular one, but we are going to need our compass. So I've got my compass here, and as you can see where the arrows are, that would be the sharp point of your compass, and where my pencil is at the top, that is where the pencil lands. So I'm going to put the compass point on C. I'm then going to extend my compass past halfway. Now for this particular part, you could actually use a ruler to see where halfway is. I'm just going to make sure that I definitely go past it. Now we're going to draw a semicircle, or an arc you can call it, and we're going to make sure it's a nice big arc so that it goes all the way around, because in a moment we are going to do that from A. Now I'm not going to change the distance on the compass, but I do need to move my compass over to A, so I'm just going to rotate this round and I'm going to bring my compass point over to A. Now I need to rotate the compass drawing another semicircle, and that is going to form a nice guideline there for my perpendicular bisector. So there we go, we can move the compass out of the way. So if we move that out of the way, we now have the guidelines in order for us to draw our perpendicular bisector. So you need to get your ruler, and this isn't the easiest for me to do, but you need to join those two crossover points up nice and carefully, and then use your ruler to join that up. I'm just going to do this using my pen, so I'm going to join up from the bottom down there, and I'm going to make sure that crosses over at the top where those guidelines crossed over. So if I move my ruler out of the way now, we now have all of those points on the black line that are equal distance from A and from C. Again, you want to leave all your guidelines in for these questions, because it shows that you knew what you were doing, and you are going to pick up marks for things like this even if you don't get to a final answer. So for the next part, I'm going to have to swap colours, because otherwise we're going to get very confused with all these guidelines. It says the bench is exactly 700 meters from D. So what we're going to do is we're going to get our compass and we're going to bring it over to D, and we're going to swing a nice circle around that so that we can see all the points that are 700 meters away. So for this particular question, we have got a scale, and you can see down the bottom it says the scale is 1 centimetre is equal to 100 metres. So for 700 metres, that's going to be 7 centimetres. Again, just dividing 700 by 100 to convert that into our centimetre conversion. So if we take our ruler, we're going to want to measure out a perfect 7 centimetres. So we're going to put the point of the compass down on 0 right at the bottom of the ruler and extend the compass up to, if we can do that, up to 7 centimetres. So if we extend that up, bring that up to 7 centimetres, and that's perfectly measured out for us. So now we're going to take our compass, making sure that we don't change it, and we're going to swing a nice circle just within the shape, given that 7 centimetre line. So there we go, that has shown us all the positions within this park that are going to be 700 metres away from point D. Now we can bring our compass out the way, and we just need to figure out where it's going to go. So if we swap this over, I'm going to shade it in orange. Let's have a think about where we would shade it, or where we would mark this point. So obviously it does say it had to be in equal distance, so it has to be on that black line, that perpendicular bisector. And then it also has to be exactly 700 metres from point D. So we only have one point that it can go, and it's where the pink line and the black line cross over, and that is just here. It says to mark it with a cross, so if we put a cross just there, I've not drawn that very well, but there we go, we can just put a little cross just over that point, and that is the point where the bench would have to go. That is an equal distance from points A and C, and it is also exactly 700 metres from point D, and they are two of the constructions that we've used in this question. So it was drawing an arc or a circle around point D, and also doing a perpendicular bisector to find the points that were equidistant from those two letters A and C. So that would be our answer for this question. Let's have a look at another one. Okay, so here is our next question. It says here is a scale drawing of a garden. It says we need to plant a tree 5 metres from point C, nearer to AB than AD, and less than 3 metres from DC. Shade the region where we can plant the tree. So this time we've got 3 things to be aware of, and also we are going to shade a region rather than a point. Now if you do want to draw this out and you want to replicate it in the same size, I could just measure this rectangle for you, and as you can see it's 8.5 centimetres down, and if we want to go across, the rectangle is going to be, let's have a look, around about 13 centimetres across. So again, you don't have to draw this, but if you did want to follow along by drawing it, then you can absolutely do so. So we'll start with the first bit of information here where it says we need to plant a tree 5 metres from point C. So if we're going to go from point C, then again we're going to draw a circle around point C. But it does say it wants it to be 5 metres. So we need to have a look at our scale, and as you can see down the bottom it says the scale is 1 centimetre is equal to 1 metre. So for 5 metres that is going to be 5 centimetres. So we just want to get our ruler and measure out our compass. So again putting the compass point down at the bottom of the ruler and measuring out where 5 centimetres is. So 5 centimetres is only that far this time. So we'll put our compass point onto C, and we'll draw a nice circular arc that shows where it has to go. So there we go, that is going to be 5 metres from point C. So there we go, that's our first part. It now tells us that it has to be nearer to AB than to AD. So A to B is the line that goes across the top of the rectangle from A to B, and A to D is the line that goes downwards from A, obviously from A to D. So in order to do that, we need to do an angle bisector, because we're going to want to find the points that are closer to AB than to AD. So we need to bisect the angle in half so that we can see all of those points on that half. Now obviously this is a rectangle and not a square, so you wouldn't want to just join the point A to C, because that's not going to be a perfect angle bisector. So obviously watching the video on angle bisectors would be very helpful for this, but if you haven't watched the video on angle bisectors, I'll just explain it. So we go up to point A and we're going to put our compass on point A. And there are 2 ways to draw an angle bisector. I do it in one particular way, so I'm going to follow the process that I did on my video. So all we do is we take our compass and we're going to draw a nice arc that joins up the 2 lines, and we're going to draw a nice little arc like that, and then we just extend our compass slightly further and we're going to draw another arc, and there we go. And that's all we need our compass for, so we can put our compass out of the way now, as that's enough for us to draw our angle bisector. So if we move this out of the way, and we'll actually now join these up. So what we do at this point, so we do like what's called, well, what I call a crisscross. So I take the lower point of the first arc and join it to the higher point of the second arc, and then again the other lower point on the first arc and join it to the other higher point on the second arc. And where those lines cross over, that is going to be where our angle bisector needs to go from. So we go back to point A, and we're going to bisect the angle, and I'm going to extend that all the way to the end of the shape. And there we go, that has now split my rectangle into two halves in terms of closer to AB and closer to AD. Obviously we need to be closer to AB, so we're going to be above that line, obviously closer to the B point on the top right of the rectangle. Now we've got one more bit of information that we need to do, and that says that it needs to be less than 3 meters from DC. So in order to get less than 3 centimeters or meters from DC, we actually want to measure 3 centimeters above the line DC. I've said 3 centimeters because 3 meters would be 3 centimeters according to our scale. So if we put the ruler down the bottom of this side to start with, you can see where 3 centimeters is. And we just need to mark that up. And we're just going to put a little line here where 3 centimeters is, and then we're going to do it on the other side. So going over to the other side, and again just marking that 3 centimeters so that we know where 3 centimeters up is on both sides. Now you would want to take your ruler and join those up nice and carefully, and we have a nice straight line. And again, mine's not going to be absolutely perfect. I probably could have done that a little bit better. So I'd go again. Oh dear, that's definitely not better. There we go, that's looking perfect. So there we go, there is our line, and above that is going to be greater than 3 meters from DC, and below that is going to be less than 3 meters from DC. So now we actually want to go about shading this position on the map here, or the scale drawing. So we need to plant it 5 meters from point C, and we need it to be nearer to AB than AD, and it has to be less than 3 meters from DC. So it has to be below that pink line, and it has to be closer to AB than AD. So if we think about where this is going to be, we know that it can't be above the line, so it can't be here, it can't be over here, it can't be over here, but it has to be below that. Now we know that it also can't be closer to AD, so any of these regions here below the blue line it can't be. It can't be this little one down here either. That only leaves us with 2. So we need to plant a tree 5 meters from point C. So if it has to be 5 meters from point C for whatever reason that it can't be close to point C, it will have to be this little region here just in the middle. Otherwise it would be closer than 5 meters from point C, and it has to be at least 5 meters from point C. So that's the only region that it can be based on that bit of information, and that would be the final answer to that question. But as you can see, a question like this is pretty difficult because you've got all these construction lines all over the place, and you've got all these different bits of information. So you just need to go through them slowly, and crossing off some of the regions can be quite helpful. So obviously we've picked the easiest one to start with, which was that it had to be less than 3 meters from DC or below that pink line, which allowed us to cross off a lot of those regions. And then obviously the fact that it had to be closer to AB than AD allowed us to cross off the ones down the bottom below the blue line, and that only left us with 2 then. So we just had to think about that first piece of information, which said that we need to plant it 5 meters from point C, which just meant that it had to be above or greater than that first arc that we drew when we drew a circle around C. So there we go, that's that question, and you're going to have a go at one very similar to this, so let's have a look at that one now. Okay, so for your question, you could obviously draw out this rectangle. This is one for you to have a go at, so if you want to draw this rectangle, it is 9 centimeters high, and it is 15 centimeters along the base. It says that the scale is 1 centimeter to 2 meters, and it gives us some instructions. So if you want to have a go at this question, draw it out 9 centimeters high, 15 centimeters across, pay attention to the scale, have a go at answering it, and we're going to go over the answer in a sec. So if you're not drawing it, of course, then you can still follow along now. So let's have a go at answering this question. So it says A, B and C in the bottom right there that you can't quite see, and D in the top right. It says here is a scale drawing of an office, and we need to put a photocopier closer to B than it is to A. It says the photocopier also has to be less than 12 meters from C, shade the region where we can put the photocopier. So in order to find where is closer to B than to A, then we need to do a perpendicular bisector of the line AB. So in order to do that, we're going to get our compass and we're going to put it on one of those points from A to B. We then need to extend the compass past halfway, and we're going to draw our guidelines in to draw that perpendicular bisector. So if we draw a nice arc, well, basically a semicircle, just from there, and then we can bring it round to the other side, not changing the size of the compass, and swing another arc around, and that draws our guideline, and that is going to allow us to draw our perpendicular bisector. So we can move our compass out the way, and we can draw a nice straight line going from those two crossover points and extending it all the way through the shape. So that's that first piece of information done. We can now see where is closer to B than to A, and it has to be below that line. Now the second piece of information is telling us that the photocopier also has to be less than 12 meters from C. So paying attention to that scale that said that 1 centimetre was equal to 2 meters, if we do 12 divided by 2, that is going to be 6 centimetres. So get your ruler and put your compass on the bottom, and we're going to measure out 6 centimetres, and that is just there. Now we can move our ruler out of the way, and we're going to draw a nice arc all the way around that point C. So point C is down the bottom, and if we draw a nice arc around that, then you can see that all of those positions inside that circular arc are going to be closer or within 12 meters from C. So if we think about where we are going to shade our region, if I could move my compass out of the way, which it doesn't look like I'm going to be able to, let's just move it out of the way here, then we can actually go about shading our region. So we know it has to be, and let's read that line again, the photocopier also has to be less than 12 meters from C. So we know it can't be above the blue line, so it can't be any of these, it can't be this one, and now we just need to follow that next bit of information. So if it has to be less than 12 centimeters from C, it has to be within that pink circular arc. So it's going to have to be within this region just here, so we would shade that in, as it can't be more than 12 meters from C, which cancels off this region here. And of course this region within our guidelines there, it's the same region that I've just crossed off, but you don't want to get confused with your guidelines. So we should have had that region shaded there. If you managed to get that region on your diagram, well done, but we're going to have a look at a different type of question now, so let's have a look at that one. Okay, so this question is slightly different look, as we don't have an actual shape. We've got 3 points on a map. So we have the points A, B and C, and they kind of form this triangular shape. Now if you want to draw out again a sketch of this, again just try and draw this out to the same sort of size that it would be on a computer screen, but otherwise don't worry too much about actually getting this the exact same size. It says point T is 250 meters from point A. And then it says point T is equidistant from points B and point C. On the map, show one of the possible positions for this point. So we've got two bits of information. It's got to be 250 meters from point A. So if we read the scale there, it says that 1 centimeter is equal to 100 meters. So this is going to be between 2 and 3 centimeters. It's going to be 2.5. Again, you could divide 250 meters by 100, and that would give you the 2.5 centimeters that it has to be from point A. So if we start by drawing that, we're going to get our compass again, put it at the bottom of our ruler, measure out 2.5 centimeters, and then we're going to draw a nice circle around A, and that will show us all of the points that are within that 250 meters. So if we put it around that point, draw a nice circle around A, now we know all of the positions there that are 250 meters from point A. So it has to be somewhere within this circle, or on the outskirt of the circle on the circumference, and that all of those points around that circle are 250 meters from A. So for the second piece of information, it says that point T is equidistant from points B and C. So to get it to be equal distances from points B and C, we're going to have to draw a perpendicular bisector of B and C. So we're just going to have to join them up to form the line which we could call BC, and now we're going to want to draw a perpendicular bisector. So again, we'll get our compass, we'll put it on point C, we'll extend it past halfway, and we're going to draw a nice arc all the way round, and then we're going to move that onto point B without changing the size of the compass, and again drawing a nice arc there so that we can draw our perpendicular bisector. So we can move all of this out of the way, and now we're going to want to draw our line. So again, if I start on the right hand side so that I can extend it over past the circle, then you can see that there are 2 points where it crosses the circumference of the circle. So we want to obviously only label one of those points. As it says, show one of the possible positions for T, and those two positions where our perpendicular bisector intersects the circle are both of our points. So obviously we would only mark one of these, but if we mark them both, we could choose either this position here, or we could choose this position here. Of course, being very careful because it does say to mark one of the possible positions. So we would only mark one of those, and that would be the answer to this question. So we're going to have a go at a question very similar to this. So let's have a look at this one now, and then you can have a go and see if you can complete one of these. Okay, so if you want to have a go at this question, I've put the ruler onto the page so you can see that these points need to be around 10 centimeters from each other. Now they're not all exactly 10 centimeters from each other, it doesn't form an equilateral triangle, but as you can see, point A there is just less than 10 centimeters, and from A to B is also around about 10 centimeters. So it's not a perfect equilateral, but if you want to draw this to have a go along with me, then you need to draw these points around about those 10 centimeter mark away from each other. Of course, you could get away with just drawing a little sketch of this, as it is only practice and we're not going to get it perfect by drawing it off the screen. So if you're going to have a go, pause the video there, have a go at this question, and we'll see if your answer matches mine in just a second. Okay, so looking at this, it says A, B and C are 3 points on a map. Point T is 350 meters from B. And then it says point T is equidistant from points A and from C. So again, we are going to draw a perpendicular bisector of AC, and we are going to draw a circle around point B. So if I start by drawing the circle, we need to measure out this distance. So 1 centimetre is 100 metres again, so for 350 metres, if we divide that by 100, it's 3.5 centimetres. So if I extend my compass here to 3.5 centimetres, and we'll draw a nice circle around point B. So if I bring that up to point B, put that on my point, and I'm going to draw a nice circle. And that has finished off that first part. We now need to draw our perpendicular bisector. So again, I'm going to want to connect the lines A to C. So if we connect that up and draw a nice line, this is the line that we're going to do our perpendicular bisector of. So again, putting your compass on point C, and we're going to go past halfway and draw a nice arc. So again, finishing that arc and bringing it over to part A, or point A, and drawing another. And now we have a nice guideline for our perpendicular bisector. So joining that up, again with a ruler, I'm going to start with the bottom point, I'm going to join it up so it passes through the circle. And as you can see on this one, it joins again 2 points on the circumference, and again on this question, you only have to pick one of them. So to show one of those points, you could have picked this point here, which is exactly 350 meters from B, and you could pick this point here, which again is exactly 350 meters from B and equidistant from the points A and C. So there we go, that was the answer to that question. Hopefully you were okay with that one, and we're going to have a look at our final question to finish this video. Okay, so on to our last question. Now if you're going to draw this out, the length along the base of the rectangle is 15 centimeters, as you can see, and the height of the rectangle is 8 centimeters. So it's an 8 by 15 rectangle, and if you want to draw this out and feel free to have a go, then please do pause the video, read through the question and have a go at this one. Otherwise, let's carry on with it, but you do need to be careful with the scale here. So the scale here says that it is 1 to 30, and here is a plan of the room. It says a table is going to be placed, and then it tells us 2 bits of information. It has to be more than 180 centimeters from A and more than 150 centimeters from BC. And it wants us to shade the region where the table can be placed. Now this isn't necessarily any more difficult than any previous questions, but it's just a little bit different. So for this one here, first of all, let's go with that first bit of information. It says more than 180 centimeters from A. Well, point A we know is on the top left, but we need to take into account this scale, and that's what changed this question. So 1 to 30 means that 180 centimeters on our ruler is going to be 30 times smaller. So we need to divide that number by 30. So if we do 180 divided by 30, well, 18 divided by 3 is 6. So dividing by 180 by 30 is also going to be 6. So we need to get a 6 centimeter length for this particular part of the question. So again, if we take our compass and we put it at the start of our ruler, we should be able to get a 6 centimetre line by doing it there and just extending our compass over to 6 centimetres. So there we go, that's going to be the perfect length for us. Now we just want to place that onto A and draw a nice 6 centimetre arc around that point. And there we go, if we draw that, anywhere outside of that is now going to be 180 centimetres from A, obviously according to the real life scale. The next bit of information that we've got is that it has to be more than 150 centimetres from BC. So BC is the right hand height of the rectangle that you can see on the right hand side, and we need to make sure it's going to be 150 centimetres from that line. So we're going to need to do that on the top and the bottom of the rectangle, and again taking account of the scale. So it's going to be 30 times smaller, 15 divided by 3 is 5, so 150 divided by 30 is also going to be 5. So we need to get a 5 centimetre mark on the bottom and the top. Now again, this is going to be easy if I move my ruler this way if I can, so 5 centimetres lines up just there. So I just want to mark that on, so I know where 5 centimetres is at the top, and that is just, if I draw a little line, just up there. I'm then going to go down the bottom, measure out 5 centimetres, and that looks like 5 centimetres there. And again, just mark that out, and again, just do it as best you can. Quite difficult for me on the screen. So there we go, we can get rid of our ruler, and we need to join that up with a nice straight line. So, joining that up again with a ruler from top to bottom, and there is your straight line. Now, on the left-hand side of that line is going to be more than the 150 centimetres from BC. On the right-hand side of the line would be less than 150 centimetres from BC. So we have quite a big region here. So let's just figure out where it can't go. So it can't go less than 180 centimetres from A, so it can't go within this arc. It also can't be closer than 150 centimetres from BC, so it can't go on the right hand side of this line, which means that we have a fairly large region here. We've got all of this region in the middle that would be within our parameters. So we would shade in all of that region. So this was a slightly different question, as we didn't have to do an angle bisector or a perpendicular bisector, and we ended up with quite a large region. So as I said, not particularly any more difficult than the previous ones, but it was different. We had a different scale, and we had a slightly larger region than we had on any of these previous questions. But there we go, that was our last question looking at loci problems, and hopefully you found this video useful and helpful. If you did, please like, please comment, please subscribe. Don't forget to check out the video in the description on perpendicular bisectors and angle bisectors, but otherwise I will see you for the next video.